Hello, and welcome to the Sleepy History Channel After Dark. Tonight we're drifting off into the history of the Bermuda Triangle and the strange disappearances reported, and the truths about what actually happened. Before we dive in, if you're looking for resources to help you relax and sleep better naturally, be sure to check out the link in the description below. Let's get started. There is a place on this earth where the water runs impossibly deep, where the sky meets the sea in shades of blue that have no name, and where, for generations, sailors and pilots have looked toward the horizon and felt something shift, something they couldn't quite explain and couldn't quite shake. It isn't marked on any official map. No government claims it. No lighthouse warns you when you've crossed into it. And yet, people all over the world know exactly where it is. They call it the Bermuda Triangle. And the story of this place begins not with a disappearance, but with a shape, a rough, imaginary triangle drawn between 3 points in the western Atlantic Ocean. The island of Bermuda to the north, Miami, Florida to the west, and San Juan, Puerto Rico to the south. Within that triangle lies roughly 500,000 square miles of ocean. Some estimates put it closer to 700,000, depending on how generously you draw the lines. That's an area larger than the states of California, Texas, and Montana combined. A vast, restless body of water sitting at the intersection of the Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico, where weather systems collide, ocean currents churn, and the seafloor drops away into some of the deepest trenches on the planet. One of those trenches, the Puerto Rico Trench, reaches a depth of more than 27,000 feet, deeper than Mount Everest is tall. Whatever sinks into that darkness does not easily come back. But the Bermuda Triangle is a cultural idea, as a mystery, as something to be feared and discussed and wondered about. That story has a more specific starting point. It begins with a journalist named Vincent Gaddis, who in 1964 published an article in a pulp magazine called Argosy, in which he coined the phrase the deadly Bermuda Triangle and described a pattern of disappearances that he believed was too strange to be explained by coincidence or weather or human error. That article set something in motion that would capture the public imagination for decades. But the disappearances Gaddis was writing about, those went back much, much further. And to understand them, we have to start at the very beginning with the oldest account we have of something going wrong in these waters. That account comes from a man who had no way of knowing he was sailing into legend. His name was Christopher Columbus, and in the autumn of 1492, as he pushed westward into unknown waters in search of a route to Asia, his journals recorded something that his sailors found deeply unsettling. On the night of October 11th, Columbus noted that his compass was behaving strangely. The needle was not pointing toward magnetic north the way it should have. At the time, this was terrifying. Sailors of that era trusted their compasses the way we trust GPS today. And a compass that lied was a compass that could kill you. Columbus also wrote about seeing a strange light dancing on the water in the darkness, a flickering glow that he couldn't identify, and that disappeared before he could investigate. And then there were the strange, still patches of sea, areas where the ocean seemed to go quiet and flat in ways that felt unnatural, eerie, as though the water itself were holding its breath. Columbus and his crew survived, of course, and went on to make one of the most consequential landfalls in human history. But those early notes from his journal, the confused compass, the strange light, the uncanny calm, would echo forward through centuries of stories about this stretch of ocean. Compass anomalies, in particular, will become one of the defining features of Bermuda Triangle accounts. And as it turns out, there is a real explanation for what Columbus observed. The area around the Bermuda Triangle is one of only 2 places on Earth, the the other being a region near Japan called the Dragon's Triangle, where true north and magnetic north align closely enough that a compass needle can appear to behave erratically as it tries to reconcile the difference. It isn't supernatural, but in 1492, in the dark, far from home, with nothing but ocean in every direction, it must have felt like the world had stopped making sense. The waters Columbus crossed would, over the centuries that followed, become some of the most heavily trafficked in the world. The trade routes of the colonial era ran straight through this region. Ships carrying sugar and rum, and enslaved people in cotton and gold made the crossing over and over, season after season, year after year. And many of them never arrived. Some were lost to hurricanes, which are born in the warm Atlantic waters east of the Caribbean and frequently track right through the triangle's boundaries. Some were lost to pirates, who found the islands and cays of the Caribbean ideal for ambush. Some ran aground on the shallow reef systems that ring Bermuda and the Bahamas, systems so treacherous and so riddled with wrecks that the waters around Bermuda were once called the Isle of Devils, and sailors were instructed, wherever possible, to give the island a wide berth. Bermuda's reputation as a place of danger and supernatural dread predates the Triangle mythology by well over a century. When the English ship Sea Venture was deliberately run aground on Bermuda's reefs in 1609 to save its crew from a violent storm, the survivors spent nearly a year on the island before building new vessels and sailing on to Jamestown, Virginia. Their accounts of Bermuda described a place haunted by strange sounds and ghostly presences, sounds that turned out to be nothing more than the calls of nesting birds, but which, in the darkness and disorientation of a shipwreck, seemed like something else entirely. Those accounts are believed to have influenced Shakespeare, who wrote The Tempest, a play about a sorcerer, a storm, and a mysterious island. Around the same time those stories were circulating in London. The Bermuda Triangle, in a sense, inspired one of the greatest works of English literature before anyone had thought to give a name. By the 19th century, the disappearance of ships in the Western Atlantic had become so common that it was simply accepted as a fact of seafaring life. The ocean was dangerous. Ships were lost. That was the way of things. But in 1872, something happened that was different from all the standard tragedies, something that didn't fit the usual explanations, and that would become one of the most debated maritime mysteries in history. A brigantine called the Mary Celeste was found drifting in the Atlantic, fully intact, her sails set, her cargo undamaged, her stores of food and fresh water largely untouched, and completely, utterly devoid of human life. Her crew of 10, including the captain's wife and young daughter, had vanished without a trace. There was no sign of struggle, no sign of fire, no sign of catastrophic damage. The ship's lifeboat was gone, suggesting the crew had abandoned ship deliberately, but no one has ever been able to explain why they would have done so, or what became of them afterward. The Mary Celeste was found not in the Bermuda Triangle. She was discovered further east, between the Azores and Portugal, but she became so closely associated with the mythology of the Triangle that she is almost always included in its story. And there's something important in that association. It tells us that the Bermuda Triangle isn't really a fixed place with fixed boundaries. It's more like an idea, a category that people reach for when a maritime mystery doesn't have a satisfying explanation. The Triangle absorbs these stories, gives them a home, gives them a shape. It is, in a very real sense, a place the human imagination built around a core of genuine, unexplained events. What that imagination built would grow in the 20th century into something enormous. But before the myths could take hold, there had to be events powerful enough to anchor them. Events so dramatic, so inexplicable on their surface, that they demanded a larger explanation. And those events were coming. The age of aviation would bring the Bermuda Triangle into a new era, with new kinds of disappearances and new layers of mystery. But we are getting ahead of ourselves. For now, in the fading light of the 19th century, the ocean simply waits, patient and blue and vast, keeping its secrets close below the surface, saying nothing. There is something about the 20th century that changed the nature of disappearance. Before the age of flight, when a ship was lost at sea, the ocean had a kind of final authority over the matter. You could search the coastlines, interview survivors, examine wreckage that washed ashore, but ultimately the sea decided what you knew and what you didn't. Ships were large and slow and visible, and even so, the water swallowed them whole and offered no explanation. But when human beings learned to fly, when we lifted ourselves off the surface of the earth and moved through the air at speeds and altitudes that would have seemed impossible to every generation before us, we brought that same vulnerability into a new dimension. Now things could disappear not just from the water, but from the sky. And in the Bermuda Triangle, the sky would prove just as capable of keeping secrets as the sea below it. The story of the triangle in the 20th century really begins in earnest on a December afternoon in 1945, with a mission so routine that the men who flew it probably thought very little about it before they climbed into their aircraft. It was a training exercise, the kind that young naval aviators flew regularly out of Naval Air Station Fort Lauderdale in Florida. 5 TBM Avenger torpedo bombers, carrying 14 men in total, took off just after 2 in the afternoon on December 5th. The flight was designated Flight 19, and its planned route was straightforward. Fly east out over the Atlantic, execute a series of navigational exercises, then turn north and come back along the Florida coastline. In good conditions, it was a 2-hour trip. The planes were well maintained. The pilots were trained. There was no reason to expect anything other than a perfectly ordinary afternoon. What happened instead has been debated, analyzed, and argued over for 8 decades, and still has no fully satisfying answer. Roughly an hour and a half into the flight, radio operators at Fort Lauderdale began receiving confused transmissions from the flight's leader, Lieutenant Charles Taylor. Taylor was an experienced pilot. He had flown combat missions in the Pacific during the war, but something had gone wrong with his sense of where he was. His transmissions described a landscape of broken islands below him, which didn't match his expected position over open ocean. He told another pilot that he wasn't certain which direction was west. His compass, he said, was behaving strangely. The sky was overcast, which meant he couldn't orient himself by the sun. And as the afternoon wore on and the transmissions continued, it became clear that Taylor believed he was somewhere over the Florida Keys, south of his intended position. And so he turned his flight north and east, trying to correct his course. But he wasn't over the Keys. He was almost certainly somewhere over the Bahamas, to the east and northeast of Florida. By turning north, he was flying further out to sea, away from land, away from safety, into the darkening Atlantic. The transmissions grew more fragmented as the afternoon turned to evening. Radio static swallowed whole sentences. The signal faded in and out. Search and rescue aircraft were scrambled, including a large PBM Mariner flying boat carrying a crew of 13, but the weather was deteriorating rapidly, and visibility over the ocean was poor. And then, one by one, the transmissions from Flight 19 stopped. The last coherent signal from Lieutenant Taylor was received just before 7 in the evening, and after that, silence. All 5 planes were gone. All 14 men were gone. The mariner sent to find them was gone too. 13 more men vanished without explanation into the same stretch of ocean and sky. In a single December evening, The Bermuda Triangle had claimed 27 lives and 6 aircraft, and left behind not a single piece of wreckage, not a single body, not a single word of explanation. The United States Navy launched one of the largest air and sea searches in its peacetime history. Hundreds of aircraft and dozens of ships combed the waters east and northeast of Florida for days. They found nothing. No oil slicks, no floating debris, no life rafts, no wreckage of any kind. The official Navy investigation into the loss of Flight 19 was, by the Navy's own eventual admission, inconclusive. An early version of the report attributed the disappearance to pilot error, specifically to Lieutenant Taylor's navigational confusion, but that finding was later amended, in part because Taylor's family objected, and in part because pilot error alone couldn't account for the complete and total absence of any physical evidence. The final official conclusion was essentially that no one knew what had happened. The ocean had taken 27 men and offered nothing in return. It would be another 19 years before Vincent Gaddis would give this stretch of ocean its name, but Flight 19 was the event that made the name necessary. It was the disappearance that felt different, that felt like it crossed a line between the merely tragic and the genuinely inexplicable. And when writers and researchers began cataloging the mysteries of the area in the years that followed, Flight 19 became the centerpiece, the founding story, the one that everything else arranged itself around. It is worth noting, as some researchers have pointed out, that the Navy's own assessment suggested Taylor may have been flying with a malfunctioning compass and made a series of navigational errors that compounded each other in the darkness. It is also worth noting that the search for wreckage was conducted in extremely rough seas, that Avenger torpedo bombers were known to sink very quickly upon hitting the water, and that the combination of darkness, bad weather, empty fuel tanks, and cold Atlantic water would have given survivors almost no chance. These are not supernatural explanations. They are devastating, ordinary ones. But they don't quite close the door on the mystery, because the complete absence of physical evidence in an area that was searched so thoroughly for so long remains genuinely difficult to explain away. What Flight 19 did, culturally and psychologically, was establish a template. After 1945, the disappearances in this region began to be understood not as isolated incidents, but as part of a pattern, as pieces of something larger and stranger than any individual event. And once people began looking for that pattern, they found, or believed they found, a remarkable amount of material to work with. Ships that had gone missing without distress signals, planes that had vanished from radar mid-flight, vessels found drifting and abandoned, like latter-day versions of the Mary Celeste. Each new incident was laid against the template of Flight 19, and the template seemed to fit. The Bermuda Triangle, as an idea, was feeding itself. One of the cases that seemed to fit that template with uncomfortable precision was the disappearance of the SS Marine Sulphur Queen in February of 1963. She was a large tanker, 523 feet long, converted from an oil carrier to transport liquid sulfur. She carried a crew of 39 men and was making a routine crossing through the Gulf of Mexico and into the Caribbean when she simply ceased to exist as far as the world was concerned. Her last known position put her near the southern tip of Florida. No distress signal was received. No mayday was called. A search eventually turned up a life ring, a piece of her name board, some fragments of clothing, and very little else. 39 men and a ship the length of nearly 2 football fields had disappeared, and what remained fit into a small pile on a search vessel's deck. The Coast Guard investigation noted that the Marine Sulphur Queen was in poor structural condition, and that transporting liquid sulfur, which must be kept at extremely high temperatures to remain liquid, and which can release toxic and flammable gases, is inherently dangerous work. A catastrophic structural failure or a gas explosion was considered the most likely explanation, but no wreckage of a ship's hull was ever found. The ocean, once again, had swallowed the evidence. There was also the matter of the Star Tiger and the Star Ariel, two British South American Airways passenger aircraft that disappeared in 1948 and 1949 respectively, both on flights that passed through or near the triangle's boundaries. The Star Tiger vanished on a flight from the Azores to Bermuda in January of 1948, carrying 25 passengers and crew. The investigation found no cause. The official report famously concluded that the aircraft's fate was an impenetrable mystery. The Star Ariel disappeared almost exactly a year later on a flight from Bermuda to Jamaica with 17 people aboard. Once again, no distress signal, no wreckage, no survivors, no explanation. Two aircraft, 2 years in a row, gone from the same general area of sky. The template, for those who believed in it, seemed undeniable. But there was a man who believed otherwise, and his contribution to the Bermuda Triangle story is as important as any of the disappearances themselves. His name was Lawrence David Cush, and he was a librarian and pilot from Arizona who in 1975 published a book called The Bermuda Triangle Mystery Solved. What Cush had done was go back to the primary sources, the original newspaper reports, the Coast Guard records, the Lloyd's of London insurance files, the official investigation reports, and compare them against the accounts that had appeared in popular books about the triangle. What he found was striking. Many of the disappearances that had been attributed to the triangle had occurred outside the triangle's boundaries entirely. Many had taken place during severe storms that the popular accounts failed to mention. Several ships described as having vanished without a trace had actually been found, wrecked on reefs or recovered after storms, and that resolution had simply never made it into the mystery books. Cush's conclusion was blunt. The Bermuda Triangle, as popularly described, was a manufactured mystery, the product of sloppy research, selective reporting, and a collective desire to believe in something unexplained. Cush's book was important, and much of what he argued holds up, but it didn't close the conversation, and in some ways it deepened it. Because even after you correct the errors, even after you account for the storms that weren't mentioned and the ships that were found and the incidents that occurred outside the boundaries, there remain a handful of cases that resist easy explanation. The ocean is vast and indifferent, and sometimes ships and planes simply disappear without yielding up their secrets, not because of supernatural forces, but because the sea is not required to explain itself. The Bermuda Triangle sits at the intersection of our desire for mystery and our need for answers, and in that intersection, it has made its home. The 20th century still had much more to offer on both sides of that line. More disappearances, more investigations, more theories, both mundane and extraordinary. And in the decades ahead, science would bring new tools to bear on old questions, with results that were sometimes clarifying and sometimes only deepened the sense that this stretch of ocean operated by its own rules. But that is the story of what came next. For now, the afternoon light of December 5th, 1945 hangs over everything. 14 young men flying east into the Atlantic, their voices growing fainter on the radio, the sky darkening around them, and the ocean below, patient and deep and utterly silent. There is a particular kind of human discomfort that arises when a question refuses to be answered. We are a species that builds maps, that names things, that fills in the blank spaces on the page with explanations and theories and stories, because the alternative, the admission that something is simply unknown, sits uneasily in us. The Bermuda Triangle had, by the middle of the 20th century, become one of the largest blank spaces in the modern imagination. Flight 19 had given it a face. The Marine Sulphur Queen had given it weight. The Star Tiger and the Star Ariel had given it altitude. And now, as the 1950s turned into the 1960s and the 1960s into the 1970s, something else was happening. Something that would transform the triangle from a regional maritime curiosity into a global phenomenon. People had begun to reach for explanations. And the explanations they reached for said as much about the era they were living in as they did about the ocean itself. The post-war decades were a strange and fertile time for the human imagination. The atomic bomb had proven that the world could end in an afternoon. The space race had pushed the boundaries of what was possible outward into the cosmos. UFO sightings were being reported in newspapers with a frequency that suggested either a genuine phenomenon or a collective psychological response to the anxieties of the Cold War, or possibly both. Science felt simultaneously more powerful and more unsettling than it ever had before, capable of miracles and capable of catastrophe in equal measure. Into that climate walked Charles Berlitz, the grandson of the founder of the Berlitz language schools, a man of considerable intelligence and considerable dramatic flair, who in 1974 published a book simply called The Bermuda Triangle. It sold nearly 20 million copies. It was translated into dozens of languages. It made the triangle a household name in countries that had no coastline anywhere near it. And it did so by weaving the known disappearances together with a set of theories that went considerably beyond anything the Coast Guard or the Navy had considered in their official reports. Berlitz entertained, with varying degrees of seriousness, the possibility that the triangle's disappearances could be explained by the lost civilization of Atlantis. According to this theory, the ruins of Atlantis lay beneath the waters of the Caribbean and the Western Atlantic, and the powerful energy crystals that had once powered the Atlantean civilization were still active on the ocean floor, interfering with navigation systems, disorienting pilots, and occasionally pulling aircraft and ships beneath the surface. The theory sounds, from the vantage point of the present day, extravagant. But it had a foothold in something real. In 1968, a diver and recreational explorer named J. Manson Valentine had discovered what appeared to be a large underwater stone formation near the island of North Bimini in the Bahamas. The formation, which became known as the Bimini Road, consisted of large, flat, limestone blocks arranged in what looked, from certain angles, like a paved pathway beneath the water. Valentine believed it was man-made. Others believed it was the remnant of a road or wall from an ancient, pre-flood civilization. Geologists who studied the formation concluded, almost unanimously, that it was a natural phenomenon, a type of limestone called beach rock that fractures along regular lines as it forms, creating geometric shapes that can look artificially constructed. But the Bimini Road fed the Atlantis theory, and the Atlantis theory fed the Bermuda Triangle. And for a time in the 1970s, all three were wound so tightly together that it was difficult to discuss one without invoking the others. Berlitz also gave serious attention to the theory of extraterrestrial involvement. UFO sightings in and around the triangle had been reported for decades. Strange lights in the sky, glowing objects moving beneath the water, aircraft that appeared on radar and then simply ceased to exist. The idea that an alien intelligence might be using the triangle's waters as some kind of base of operations, or that craft and crews were being abducted by non-human entities, had a real audience in the 1970s. Not just among fringe believers, but among people who considered themselves reasonable and scientifically minded. The decade was, in some respects, the high water mark of popular UFO culture, and the Bermuda Triangle sat comfortably within that broader conversation. Some researchers even propose that the triangle was a portal, a doorway in the fabric of space or time through which ships and planes were passing involuntarily, emerging somewhere else or someone else, stranded in another dimension or another era. It was an idea that owed more to science fiction than to science, but it captured something real about the mystery's emotional core. The sense that these disappearances weren't just tragic but transgressive, that they violated the ordinary rules of the physical world. What is interesting, looking back at that period, is how much the triangle mythology reflected its cultural moment. In an era of space exploration and atomic anxiety and Cold War uncertainty, the idea that there were forces at work in the world, powerful, invisible, possibly malevolent, that operated beyond human understanding resonated deeply. The triangle gave those forces a geography, a set of coordinates, a place on the map where the inexplicable had a home, and the stories multiplied. New disappearances were added to the catalog. Old ones were reinterpreted through the lens of the new theories. The triangle became, in the words of one researcher, a kind of mythology in real time, a living, growing body of narrative that absorbed new material and organized it around a central, unfalsifiable mystery. But even as the mythology was reaching its cultural peak, the scientific community was beginning to push back, and not just with the debunking work of Lawrence Kusch, which we encountered in our last chapter. Oceanographers, meteorologists, geologists, and aviation experts began examining the specific conditions of the triangle with fresh eyes, and what they found was a region of extraordinary and genuinely unusual natural complexity. The Gulf Stream, for instance, that powerful, warm ocean current that flows northward along the eastern coast of North America before turning east across the Atlantic, runs directly through the triangle's western boundary. The Gulf Stream moves at speeds of up to 5 knots, which is fast for an ocean current, and its interaction with the cold waters of the deep Atlantic creates conditions of turbulence and unpredictability at the surface. More significantly, the Gulf Stream is extraordinarily efficient at dispersing debris. A ship that sinks in the Gulf Stream doesn't leave wreckage floating in place. The current carries that wreckage away rapidly, scattering it over hundreds of miles of open ocean, making it effectively invisible to search parties. The absence of wreckage that had seemed so mysterious in case after case, Flight 19, the Marine Sulphur Queen, the Star Tiger, had a perfectly natural explanation. The ocean was not hiding the evidence. The ocean was moving it. The weather of the region added another layer of complexity. The Western Atlantic and the Caribbean are among the most meteorologically dynamic environments on Earth. Storms can form with extraordinary speed. A clear sky can become a violent squall within minutes, with no warning and no time for a crew to respond. The warm waters of the Caribbean feed these storms, giving them energy that cold water systems simply don't have. Waterspouts, essentially tornadoes that form over water, are common in the triangle's boundaries, and a waterspout striking a small aircraft or a sailing vessel could destroy it so quickly and so completely that no distress signal would be possible. Lightning in tropical storms is of a frequency and intensity that exceeds almost anything found in temperate climates. A plane flying into a tropical supercell at night, with limited visibility, disoriented instruments, and a crew relying on radio contact that the storm itself might be disrupting, is in a situation of genuine, extreme danger. And many of the disappearances that have been cataloged as mysterious had occurred in exactly those conditions. There was also the matter of the seafloor. The Bermuda Triangle sits above one of the most geologically complex regions of the Atlantic Basin. The Puerto Rico Trench, already mentioned for its staggering depth, is part of a zone of significant tectonic activity. The Caribbean plate grinds against the North American plate along a boundary that runs directly beneath the triangle's southern waters, producing earthquakes and, more relevantly, methane hydrate deposits, massive accumulations of frozen methane gas that sit beneath the ocean floor in a crystalline, ice-like form. Under certain conditions, a change in temperature, a shift in pressure, a small seismic disturbance, these methane hydrate deposits can destabilize and release enormous quantities of gas very rapidly. When this happens, the water above the release site becomes saturated with methane bubbles, its density dropping dramatically. A ship caught above a methane release of sufficient size would find that the water was no longer capable of supporting it. It would sink, not because of a hole in its hull or a failure of its engines, but because the sea beneath it had temporarily ceased to be seawater in any meaningful physical sense. After the release, the water returns to normal. The surface shows nothing. The ship is simply gone. This methane hydrate hypothesis was proposed by Australian scientist Joseph Monahan and his colleague David May in 2003, and it attracted considerable attention because it offered a mechanism, a real, physically plausible mechanism, for the kind of sudden, inexplicable sinking that the triangle's worst cases seem to involve. It doesn't explain the aircraft disappearances, and it remains a hypothesis rather than a confirmed cause of any specific incident. But it represented something important in the evolution of the triangle story. The moment when science stopped simply dismissing the mystery and started genuinely engaging with it, asking not just whether the disappearances were real, but what natural forces might be capable of producing them. The ocean, it turned out, had plenty of natural forces to offer. And as the 20th century moved toward its close, the question was no longer whether the Bermuda Triangle was a place of genuine danger. The honest answer to that question was complicated and depended heavily on how you defined your terms and drew your boundaries, but whether the danger was of a kind that required supernatural explanation. For the scientists, increasingly, the answer was no. For the storytellers and the believers, that answer would never quite be satisfying, because what the triangle offered was something that science, by its nature, was not equipped to provide. It offered the feeling of standing at the edge of the known world and looking out into darkness. It offered the particular, irreplaceable thrill of not knowing, and that, perhaps more than any specific disappearance or any specific theory, is what has kept the Bermuda Triangle alive in the human imagination for so long. There are still stories to be told, though. Still cases that the scientific explanations didn't fully account for. Still moments when the evidence, examined closely, seemed to resist the ordinary and reach toward something else. Those stories were waiting, in the logbooks of ships that had passed through the triangle and come out the other side with something strange to report, in the testimonies of pilots who had experienced phenomena they couldn't explain, and in the depths of the ocean itself, where the darkness is absolute and the pressure is immense, and whatever has sunk there has not yet given up its secrets. The triangle was not finished with its storytelling, not by a long way. There is a particular kind of witness that history tends to overlook. Not the scientists with their instruments, not the investigators with their reports, not the authors with their theories, but the ordinary person who was simply there, who looked out a window or over a railing and saw something that didn't fit the world they thought they understood, and who spent the rest of their life trying to find a language adequate to describe it. The Bermuda Triangle has produced many such witnesses. Pilots who landed safely but couldn't account for missing time. Sailors who navigated through the triangle without incident but reported compass readings that made no sense. Skies that changed color in ways they had never seen before, and a quality of silence over the water that felt, as one captain described it, like the silence inside a building rather than the silence of open ocean. These accounts are not evidence in any scientific sense. They are not proof of anything, but they are data of a different kind. Testimony about what it feels like to move through this particular stretch of the world. And that testimony, taken as a whole, describes something genuinely unusual. One of the most striking of these first-hand accounts came from a commercial pilot named Chuck Wakely, who in 1964 was flying a small plane from Nassau in the Bahamas to Miami, Florida, a short, routine flight across the western edge of the triangle. The night was clear. His instruments were functioning normally. He was at cruising altitude, settled into the kind of alert but relaxed attention that experienced pilots maintain on familiar routes. And then, gradually, the wings of his aircraft began to glow, not from any internal source, not from the aircraft's own lighting systems, but with a soft, bluish-white luminescence that spread from the wingtips inward along the fuselage. His instruments began to malfunction. His compass spun. His radio produced static where there had been clear communication. The glow intensified, surrounding the entire aircraft in what he described as a cocoon of cold light. And then, as gradually as it had come, it faded. His instruments returned to normal. His radio cleared. He landed in Miami without further incident and filed a report describing what he had experienced. He could not explain it. Neither could anyone he reported it to. What Wakely almost certainly encountered was a natural phenomenon called St. Elmo's fire, a form of plasma discharge that occurs when the electrical field in the atmosphere becomes sufficiently intense, usually in advance of a thunderstorm or in areas of high electromagnetic activity. The phenomenon has been observed and documented since antiquity. Ancient sailors saw it dancing at the tops of their masts and regarded it as a sign from the gods, sometimes as an omen of disaster, and sometimes as a mark of divine protection, depending on the circumstances. St. Elmo's fire is not dangerous in itself, but it can interfere with electronic instruments, disrupt radio communication, and, most significantly, cause compass needles to behave erratically. In a region already prone to the kind of atmospheric conditions that produce electromagnetic disturbances, it may be far more common than the general public realizes. And for a pilot or a sailor encountering it for the first time, in the dark, over open ocean, with instruments suddenly unreliable and the air around them glowing with cold fire, it would be a deeply unsettling experience, the kind that lodges in the memory and resists ordinary explanation. The electromagnetic peculiarities of the triangle have attracted serious scientific attention over the years, and what researchers have found is that the region does appear to have unusual properties in this regard. The interaction between the Gulf Stream and the colder Atlantic water creates temperature differentials that can produce localized atmospheric effects of considerable intensity. The underlying geology, the tectonic activity, the methane deposits, the unusual configuration of the ocean floor may contribute to electromagnetic anomalies at the surface. And the fact that the triangle sits in a zone where magnetic declination, the difference between true north and magnetic north, changes significantly over relatively short distances means that a navigator relying on a magnetic compass without correcting for declination can find themselves significantly off course without any instrument malfunction at all. Columbus noticed this in 1492. Pilots and sailors have been noticing it ever since. It is a real, measurable, scientifically documented feature of the region. It just doesn't require a supernatural explanation to account for it. But the electromagnetic dimension of the triangle story opens a door onto something else, something that sits at the edge of established science and looks out into territory that is considerably less certain. In the 1970s, a number of researchers began investigating the possibility that the triangle's anomalies were connected to what they called electronic fog, a phenomenon described by multiple pilots and sailors as a strange, thick mist that appeared without warning, surrounded their craft completely, caused all electronic instruments to fail simultaneously, and produced a sensation of disorientation so profound that the people inside it lost all sense of direction, altitude, and time. The fog would lift, sometimes after minutes, and sometimes after what felt like much longer, and the crew would find themselves in a different position than their last known location, with no memory of how they had gotten there and no record on their instruments of the intervening time. The most detailed account of this phenomenon came from a pilot named Bruce Jernon, who in December of 1970 was flying a Beechcraft Bonanza from Andros Island in the Bahamas to Palm Beach, Florida, with his father and a business associate aboard. Shortly after takeoff, Jernon encountered an unusual cloud formation, a large, lens-shaped cloud sitting unusually low over the water, which he decided to fly above rather than around. As he climbed, the cloud seemed to climb with him. When he finally topped it and leveled off, he found himself inside what he described as a tunnel, a cylindrical opening through the cloud formation, with the walls of the tunnel rotating slowly around him and a bright, hazy light visible at the far end. He flew toward the light and emerged to find himself over Miami Beach, looking down at the coastline, with his instruments showing that the flight had taken only 47 minutes. The flight should have taken 75 minutes at minimum. He had covered the distance significantly faster than was physically possible given his aircraft's speed, and he could not account for the missing time or the impossible distance. Jernon spent decades researching what he had experienced, and eventually proposed a theory involving what he called electronic fog and a related concept of time displacement. The idea that the electromagnetic conditions inside certain triangle formations could compress or distort the experience of time and space for those caught within them. His account has been neither proven nor definitively disproven. Aviation researchers who have examined it note that disorientation, instrument malfunction, and inaccurate time perception are all known effects of certain atmospheric conditions, and that a pilot experiencing them might genuinely believe they had traveled faster than was possible, when in fact they had simply lost accurate track of their position and timing. But Jernon himself, who was an experienced pilot with no prior history of unusual experiences, maintained until his later years that what he encountered was something the existing scientific framework was not equipped to explain. He was not a sensationalist or fantasist. He was a careful observer describing something that happened to him, and the honesty of his account, its specificity, its lack of embellishment, its acknowledgement of uncertainty, gives it a weight that more dramatic stories sometimes lack. What these first-hand accounts collectively suggest, whether or not one accepts any supernatural interpretation, is that the Bermuda Triangle is a place where the ordinary conditions of flight and navigation can become, very quickly and very unexpectedly, extraordinary. The weather, the electromagnetic environment, the ocean currents, the depth and complexity of the seafloor, all of these create a physical context in which standard procedures and standard instruments may not behave in standard ways. And when the ordinary tools of navigation fail, when the compass lies and the radio speaks static and the sky looks wrong, the human mind is left to its own resources, to memory and instinct and the ability to reason clearly under pressure. Sometimes those resources are sufficient, sometimes they are not. And in the gap between sufficient and not sufficient, the Bermuda Triangle has claimed what it has claimed. Among the cases that fall into that gap, few are more quietly haunting than the disappearance of a young pilot named Jose Torres in 1978. Torres was flying a small Cessna from Puerto Rico toward the Dominican Republic a short flight over water that should have presented no significant challenge for a pilot of his experience. He filed a flight plan, made routine radio contact as he departed, and then, somewhere over the waters between the two islands, simply ceased to transmit. No distress call, no indication of mechanical trouble, no sign of bad weather in the area at the time of his disappearance. A search found nothing. Torres and his aircraft were gone in the way that the Triangle's victims often go, completely, cleanly, as though they had been removed from the world rather than lost in it. Torres's case is not among the famous ones. It does not appear in most popular books about the Triangle. It is a small disappearance, a quiet one, the kind that the ocean absorbs without drama and history forgets without ceremony. But it stands for something important. For the hundreds of cases, most of them unknown outside the families they devastated, that don't rise to the level of Flight 19 or the Marine Sulphur Queen, but that together form the true texture of the Triangle's history. Real people, going about ordinary business, crossing a stretch of water or sky that had been crossed 10,000 times before them, and not arriving. The famous cases get the books and the documentaries and the theories. The quiet cases get silence. And the silence, in its own way, is the most honest thing the Triangle offers. A reminder that the ocean does not discriminate between the historically significant and the forgotten, between the cases that become legends and the cases that become nothing at all. By the time the 20th century was drawing to a close, the Bermuda Triangle occupied a peculiar position in the cultural landscape. It had been debunked repeatedly and with some rigor. It had been explained, in part, by science. It had been inflated by popular culture into something considerably larger and more dramatic than the evidence strictly warranted. And yet it persisted. It persisted because the genuine cases, the ones that resisted easy explanation even after the errors were corrected and the storms accounted for, remained genuinely unresolved. It persisted because the ocean is real and the disappearances are real and the families left behind are real. And it persisted because human beings confronted with a blank space on the map will always lean in to look more closely, driven by the oldest and most irresistible of all our instincts, the need to know what is out there, past the edge of what we can see in the dark water at the end of the world. The 21st century would bring new tools to that search. Satellite imaging, deep-sea submersibles, advanced meteorological modeling, and the accumulated data of decades of oceanographic research would all be brought to bear on the Triangle's mysteries, with results that were sometimes clarifying and sometimes deep in the sense that certain questions would not yield to any instrument yet built. But there are also new disappearances, because the Triangle, whatever its ultimate nature, was not finished. The ocean never is. Every mystery has a geography, and the geography of the Bermuda Triangle is not simply a matter of latitude and longitude. It is a geography of the imagination as much as of the physical world. A landscape shaped as much by what people have believed about it as by what the ocean and the sky have actually done there. But beneath the mythology, beneath the theories and the books and the documentaries and the decades of speculation, there's a real place. And that real place, examined closely, is one of the most scientifically complex and naturally dramatic environments on the surface of the Earth. To understand the Triangle fully, to hold both the mystery and the explanation in the same hand at the same time, you have to spend some time with the place itself, with its water and its weather and its floor and its currents, because the physical reality of the region is strange enough and dramatic enough and genuinely dangerous enough that it needs no embellishment to command attention. Begin with the water. The Western Atlantic and the Caribbean Sea, which together form the Triangle's liquid body, are among the warmest ocean waters in the world. The surface temperature in the triangle's boundaries averages somewhere between 75 and 85 degrees Fahrenheit for much of the year, and those warm waters are the engine that drives everything else about the region's character. Warm water evaporates more readily than cold water, pumping enormous quantities of moisture into the atmosphere above it and creating the conditions for the kind of convective storms, towering, violent, fast-moving, that are the Caribbean's most dangerous meteorological feature. A storm that begins as a modest cluster of thunderclouds over warm water can, within hours, organize itself into something ferocious. A squall line that stretches for hundreds of miles, or the early stages of a tropical cyclone that will eventually become a hurricane. The triangle sits squarely in the main development region for Atlantic hurricanes, the zone where the majority of the Atlantic Basin's most powerful storms are born or reach their peak intensity. Between June and November, every season without exception, the waters of the triangle are potential hurricane country, and hurricanes have been responsible for more maritime losses in this region than any other single cause. But hurricanes, for all their power, are at least visible on modern radar and satellite imagery, trackable days in advance, their paths predictable enough that ships and aircraft can generally avoid them. The more insidious meteorological dangers of the triangle are the ones that come without warning. The microbursts, the waterspouts, the localized squalls that appear from a clear sky in minutes and disappear just as quickly, leaving nothing behind but disturbed water and, sometimes, wreckage. A microburst is a sudden, powerful downdraft of cold air from a thunderstorm cell, a column of air descending so rapidly that it hits the ocean surface and spreads outward in all directions at speeds that can exceed 100 miles per hour. For a small aircraft caught beneath a microburst, there is essentially no response time. The downdraft pushes the plane toward the water faster than any engine can compensate, and the result can be catastrophic before the pilot has processed what is happening. For a small boat, the outward blast of wind at the surface can capsize it in seconds. And because microbursts are localized, sometimes only a few hundred meters across, they may occur in an area where the surrounding weather appears benign, leaving no atmospheric context to explain what went wrong. Waterspouts are similarly capricious. A waterspout is, in essence, a tornado that forms over water, drawing a column of rotating air and spray from the ocean surface up into the base of a cloud. They are common in the warm waters of the Caribbean, far more common than most people realize, with some areas of the Florida Straits and the Bahamas experiencing dozens of waterspouts in a single afternoon during the right atmospheric conditions. Most waterspouts are relatively weak by tornado standards, but a strong waterspout striking a small vessel or a low-flying aircraft can destroy it so suddenly and so completely that no distress signal is possible. And because waterspouts move across the water, sometimes at considerable speed, and because they can occur in conditions that don't otherwise suggest severe weather, they represent a hazard that is genuinely difficult to anticipate or avoid. Several researchers who have revisited the Triangle's catalog of disappearances have suggested that waterspouts, perhaps more than any other single phenomenon, account for the small boat and light aircraft cases that resist more obvious explanations. Then there is the seafloor. The floor of the ocean beneath the Bermuda Triangle is one of the most varied and dramatic underwater landscapes on Earth. A terrain that shifts within relatively short distances, from shallow reef systems to abyssal trenches of almost incomprehensible depth. The shallow waters around the Bahamas and Bermuda itself are riddled with coral reefs, sandbars, and underwater ridges that have been claiming ships since the first European vessels entered these waters in the late 15th century. These reefs are not always charted with perfect accuracy, particularly the smaller and more isolated formations. And a vessel navigating in darkness or in poor visibility can find itself aground on a reef that wasn't on its chart before anyone aboard has had time to react. Grounding on a reef in the open ocean is frequently fatal. The waves push the vessel further onto the reef with each swell, breaking it apart progressively, and the same reef that destroyed the ship prevents rescue vessels from approaching closely enough to help. Beyond the reef systems, the seafloor drops away with startling abruptness into depths that are, for all practical purposes, inaccessible. The Puerto Rico Trench at the triangle's southeastern edge descends to 27,841 feet at its deepest point, a depth at which the water pressure is more than 8,000 pounds per square inch, enough to crush any conventional submarine, and to compress the wreckage of a ship or aircraft into a fraction of its original volume. Even with the most advanced deep-sea submersible technology available today, exploring the Puerto Rico Trench is an extraordinarily difficult undertaking. The trench is vast, hundreds of miles long and tens of miles wide, and searching it for specific wreckage is an exercise in finding objects smaller than a football field in a volume of water roughly the size of the state of Texas, in complete darkness, at pressures that make every mechanical system aboard a submersible work at the very edge of its tolerance. The things that have sunk into the Puerto Rico Trench have not been found because they cannot, with current technology, practically be found. That is not a mystery. That is simply the nature of deep water. The Gulf Stream, which flows northward through the triangle's western boundary at speeds of up to 5 knots, adds another dimension of complexity to the seafloor picture. The stream doesn't just disperse surface debris. It also creates a dynamic underwater environment in which sediments are constantly moving, in which the boundary between the warm stream water and the cold Atlantic water to its east generates turbulence that extends deep below the surface. Objects that sink in or near the Gulf Stream don't simply fall straight down. They are carried laterally by the current as they descend, potentially traveling dozens of miles horizontally before reaching the bottom, ending up nowhere near where a search based on their last known position would look for them. The stream is, in effect, a moving highway that runs through the heart of the triangle, and anything that enters it, wreckage, debris, the evidence of a disaster, is taken somewhere that a search party may never find. It is worth pausing here to consider what all of this means in aggregate, because what the science of the triangle reveals, when you lay it all out together, is not a place where supernatural forces have conspired to create mystery, but a place where an extraordinary concentration of natural forces, meteorological, oceanographic, geological, electromagnetic, have combined to create an environment of genuine, layered, compounding danger. Any one of these factors alone, the hurricanes, the microbursts, the waterspouts, the shallow reefs, the abyssal depths, the Gulf Stream dispersal, the methane hydrate deposits, the electromagnetic anomalies, the rapid weather changes, would be sufficient to explain occasional maritime and aviation losses. Together, operating simultaneously and interactively, they create conditions in which the probability of disaster is meaningfully higher than in most comparable stretches of ocean, and in which the probability of finding evidence afterward is meaningfully lower. The triangle doesn't need to be supernatural to be dangerous. It just needs to be itself. And yet, and this is the tension at the heart of the story, the tension that no amount of scientific explanation has entirely resolved, there remain cases that don't fit neatly into any of these categories. Cases where the weather was clear and the sea was calm and the crew was experienced and the aircraft or vessel was well maintained, and where something still went wrong in a way that left no trace and offered no explanation. These cases are fewer than the mythology suggests, and some of them, may eventually yield to explanations that simply haven't been found yet. But they exist, and their existence matters because they remind us that the ocean is not a problem that has been solved. It is an environment of almost incomprehensible scale and complexity, and our understanding of it, for all the sophistication of modern oceanography, remains partial and provisional. One such case is the disappearance of the Ellen Austin. Though its story comes from an earlier era, it belongs in this scientific chapter because it illustrates so perfectly the gap between what we can explain and what we cannot. In 1881, the American schooner Ellen Austin reportedly encountered a derelict vessel in the North Atlantic, sailing with no crew aboard. The Ellen Austin's captain put a prize crew on the derelict and instructed them to sail it to port. The two ships became separated in a squall. When they found each other again, the prize crew had vanished. The derelict was once again empty, drifting, its deck silent. The captain, reportedly undaunted, put a second crew aboard. The ships became separated again. The derelict was never seen again. The Ellen Austin herself returned to port with her captain's account of what had happened, and with no further explanation to offer. Researchers have questioned the details of this account. Some have suggested that the story was embellished or even fabricated in subsequent retellings, and the primary sources for it are not as solid as one would wish. But the story persists because it captures something essential about the triangle's character. The sense that it is not merely dangerous, but specifically, peculiarly, inexplicably so. That it doesn't just kill people, but erases them, removing them from the world so completely that even the evidence of their removal is itself removed. Other oceans have shipwrecks. The Bermuda Triangle, at its most mysterious, seems to have something else, an appetite for finality, a preference for leaving no trace, a quality of thoroughness in its disappearances that goes beyond what weather and current and depth alone seem to account for. Whether that quality is real, whether it reflects something genuinely anomalous about the region, or whether it is a pattern that human beings have imposed on random data, because we are a species that sees patterns even where none exist, is a question that the evidence cannot definitively answer. What it can answer, and what the science clearly shows, is that the triangle is a place where the natural world operates at a level of intensity and complexity that demands respect. Not fear, necessarily. Not the kind of superstitious dread that once made sailors give Bermuda a wide berth and name it the Isle of Devils, but a careful, informed, eyes-open respect for a stretch of ocean that does not forgive carelessness, does not offer second chances, and does not, as a rule, give back what it takes. The 21st century was bringing new eyes to these old waters, and what those eyes were finding was both illuminating and, in its own way, deepening. Because the more carefully scientists looked at the triangle, the more they found that the real story, the story beneath the mythology, was in some respects more interesting than the mythology itself. There is a moment in the life of any great mystery when the tools available to investigate it finally catch up to the questions being asked. For most of the Bermuda Triangle's history as a subject of serious inquiry, those tools were inadequate. Searchers had ships and aircraft and naked eye, and the ocean is simply too large and too deep and too indifferent to yield its secrets to instruments that modest. But the 21st century brought something different. It brought satellite systems capable of imaging the ocean surface in near real time. It brought deep-sea submersibles that could reach depths previously accessible only to the imagination. It brought sophisticated meteorological modeling that could reconstruct the atmospheric conditions of a specific place at a specific moment decades in the past, allowing investigators to go back to the scene of a disappearance and ask, with genuine precision, what the weather was actually doing on that particular afternoon. It brought sonar mapping technology that could render the ocean floor in 3 dimensions, revealing features that no previous survey had detected. And what all of these tools found, when they were turned toward the triangle, was a picture more complex and more textured than either the believers or the debunkers had previously described. The sonar mapping work was perhaps the most visually dramatic of these contributions. In the early years of the 21st century, oceanographic surveys using multi-beam sonar, a technology that sends out dozens of sonar pulses simultaneously and assembles their returns into a detailed 3-dimensional image of the seafloor, began to reveal the underwater landscape of the Bermuda Triangle in unprecedented detail. What they found beneath the Western Atlantic and the Caribbean was a terrain of extraordinary variety and strangeness. There were underwater mountain ranges, their peaks rising thousands of feet from the abyssal plain. There were vast, flat plateaus of sediment, as featureless as a desert. There were canyons that dwarfed anything on the terrestrial surface, cutting through the ocean floor in sinuous channels that ran for hundreds of miles. And there were, scattered across this landscape, the wrecks, hundreds of them, from every era of maritime history, lying where they had come to rest after whatever final catastrophe had claimed them. Some of these wrecks were known, some were not, and their distribution across the seafloor told a story that was, in its own way, as informative as any of the individual disappearance cases. The wrecks clustered in predictable places, near the reef systems around Bermuda and the Bahamas, where grounding had always been the primary hazard, in the deeper water along the Gulf Stream's path, where storms had claimed vessels that were then carried south and east by the current before sinking, and in the approaches to major ports, where the density of traffic ensured that any given stretch of water had seen more voyages, and therefore more losses, than the open ocean. This distribution suggested something important, that the pattern of disappearances in the triangle, to the extent that a pattern existed, was consistent with the known hazards of the region rather than with any anomalous force operating outside those hazards. The wrecks were where you would expect to find them, given what the ocean did to ships in those locations. They were not randomly distributed. They were not concentrated in any specific zone within the triangle that might suggest a localized phenomenon. They were where the reefs were, and where the storms were, and where the traffic was heaviest. But the sonar surveys also found things that were harder to categorize. In the deep water of the triangle's interior, far from the reef systems and the shipping lanes, the surveys occasionally revealed objects on the seafloor that didn't immediately resolve into recognizable shapes. Formations that were too regular to be obviously geological, but too poorly preserved to be definitively identified as man-made structures. Some of these were almost certainly natural features. The ocean floor produces geometric shapes through entirely natural processes, as we saw with the Bimini Road, and the human eye is exquisitely well designed to find recognizable patterns in ambiguous data. Others remained uncertain even after extended analysis, their origin and nature genuinely unclear. None of them has been definitively identified as evidence of anything anomalous, but their existence serves as a reminder that the ocean floor, even in a heavily studied region like the Western Atlantic, still contains things we haven't cataloged and processes we don't fully understand. The satellite oceanography work contributed something different and equally valuable, a new understanding of the surface conditions that have historically made the triangle so dangerous for mariners and aviators. In 2016, a team of researchers from the University of Southampton in England analyzed satellite radar images of the ocean surface in the North Sea and found evidence of what they called rogue waves, enormous, isolated waves of extraordinary height that appear suddenly in otherwise moderate sea conditions, without the warning that ordinary storm waves provide. These rogue waves, sometimes reaching heights of 100 feet or more, had long been considered by maritime scientists to be extremely rare, possibly even mythological. Sailors had reported them for centuries, but the scientific community had been skeptical because the standard mathematical models of wave behavior couldn't easily account for them. The satellite data showed that they were not rare at all. They occurred regularly in multiple ocean basins, under conditions that didn't obviously predict them. And the researchers noted that the warm, dynamic waters of the Western Atlantic, the Bermuda Triangle's home waters, were among the environments most conducive to rogue wave formation, because the interaction between the Gulf Stream and the surrounding ocean created the kind of wave energy focusing that could, under the right circumstances, produce a wave of catastrophic size from a sea state that appeared relatively benign. A rogue wave striking a large vessel can cause catastrophic structural damage in seconds. For a smaller vessel, the result would be instantaneous and total. The wave comes, the boat is gone, and within minutes the sea state returns to something that looks, to a rescue aircraft arriving on the scene, like moderate ocean conditions. Nothing that should have caused a disaster. No wreckage, because the wave energy that destroyed the vessel also dispersed whatever remained across a wide area. No survivors, because no one survives a breaking wave of that size at close range. No explanation visible in the sea conditions, because the rogue wave itself has already passed. It is, in effect, the perfect instrument for creating exactly the kind of mystery the Bermuda Triangle is famous for. A disappearance that leaves no evidence and admits no obvious cause. The atmospheric scientists were finding equally sobering things in the meteorological record. Using modern reanalysis data, a technique that combines historical weather observations with contemporary atmospheric modeling to reconstruct past weather conditions with high precision, researchers began revisiting some of the Triangle's most famous disappearance cases and asking what the atmosphere was actually doing at the time. What they found, in case after case, was that the weather at the moment of disappearance was significantly worse than the official accounts had suggested. For Flight 19, the reanalysis data showed that the atmospheric conditions over the eastern Bahamas on the afternoon of December 5, 1945 were deteriorating more rapidly than the weather reports available to the crew at the time had indicated. That the combination of overcast skies, failing light, shifting winds, and the kind of localized squall activity that doesn't always show up clearly in broad weather reports had created a navigational environment of genuine severity. For the Star Tiger, the reanalysis suggested that the headwinds the aircraft encountered on its final flight from the Azores were considerably stronger than forecast, which would have increased its fuel consumption significantly and potentially left it short of Bermuda with no reserve to spare. None of this constitutes proof of what happened in these specific cases. Reanalysis data is a reconstruction, not a recording, and its precision decreases as you go further back in time. But it consistently pointed in the same direction, toward weather that was worse than previously understood, operating in an environment that was already at the edge of navigational tolerance. It suggested that the margin between a routine flight and a fatal one, in the Triangle's atmospheric conditions, was narrower than the crews involved may have realized, and narrower than the subsequent investigations, working with less sophisticated meteorological tools, had appreciated. The satellite technology also brought something that earlier investigators could only have dreamed of: the ability to search the ocean surface in near real time, over vast areas, without the limitations of human observers and aircraft. When vessels or aircraft go missing in the modern era, satellite imagery, can be deployed within hours to scan the area around the last known position, looking for debris fields, oil slicks, or life rafts. This capability has transformed the search and rescue picture in the Triangle as everywhere else, and it has had an interesting side effect on mythology. Because in the modern era, disappearances in the Triangle that leave no trace have become genuinely rarer. Not because the ocean has become less dangerous, but because the tools available to find evidence have become so much more powerful that the evidence, when it exists, is now more likely to be found. The cases that leave no trace at all, the ones that feed the mystery most powerfully, are increasingly the ones where there was simply nothing left to find, because the destruction was too complete, or the depth too great, or the dispersal too rapid. And that, in a strange way, is its own kind of answer. There was one more scientific contribution that deserves attention in this chapter, and it came not from oceanography or meteorology, but from the insurance industry, a source of empirical data that is sometimes overlooked in discussions of the Triangle, but that carries considerable evidential weight. Lloyd's of London, the venerable British insurance market that has been underwriting maritime risk for more than 3 centuries, was asked repeatedly over the years whether it charged higher premiums for vessels crossing the Bermuda Triangle than for comparable voyages elsewhere. The answer, consistently and without equivocation, was no. Lloyd's actuaries, people whose professional function is to assess risk with the greatest possible accuracy, because their livelihood depends on getting that assessment right, did not find that the Bermuda Triangle represented a statistically elevated risk compared to other heavily trafficked stretches of ocean. The United States Coast Guard, which maintains detailed records of maritime incidents in American waters, reached a similar conclusion when it examined the Triangle's disappearance rate against comparable ocean regions. The rate of incidents per vessel crossing was not significantly higher in the Triangle than in the North Sea, or the waters around Japan, or several other regions that carry no supernatural reputation at all. This actuarial perspective is, in some ways, the most deflating thing that can be said about the Bermuda Triangle as a place of special danger. It suggests that the concentration of disappearances there is not a concentration at all, when measured against the volume of traffic that passes through the region, that the Triangle appears mysterious partly because it is one of the most heavily traveled stretches of ocean in the world, and more traffic means more incidents, and more incidents means more material for mystery-minded writers and researchers to work with. The Triangle, by this accounting, is not more dangerous than other places. It is more famous than other places, which is a different thing entirely. And yet the cases remain. The men of Flight 19 remain. The crew of the Marine Sulphur Queen remain. The passengers of the Star Tiger remain. Whatever the statistics say about the Triangle as a category, the individual cases within it are real, and the people lost in them were real, and the absence of explanation in the hardest cases is real. The science has narrowed the mystery considerably, has given natural accounts for phenomena that once seemed to require supernatural ones, has shown that the Triangle is a dangerous place for entirely understandable reasons, but has not emptied the mystery entirely. And in what remains, in the residue that the scientific explanations don't quite dissolve, the Triangle continues to exert its pull on the imagination, on the curiosity, on the deep human need to understand what happens at the edge of the known world, where the charts run out and the water goes on forever. Every story has its human heart, not its theories, not its evidence, not its scientific explanations or its supernatural alternatives, but the people at its center, the ones who lived inside the events that everyone else would later analyze and debate and write books about. We have spent considerable time in this story with the facts and the forces, the weather systems and the ocean currents and the electromagnetic anomalies and the actuarial tables. And those things matter. They are the bones of the story. But the flesh of it, The part that makes it live is the people, the sailors and the pilots and the passengers, the families who waited on shore for ships and planes that never arrived, and the searchers who went out looking and came back with nothing. This chapter belongs to them. Begin with the mothers. There is a particular quality to the grief of a mother whose child has been lost at sea, and it is different from ordinary grief in one specific and terrible way. It has no object. Ordinary grief, however devastating, has something to attach itself to. There is a body, a grave, a place where the loss is located, a physical fact around which mourning can organize itself. The grief of a mother whose son flew into the Bermuda Triangle on a December afternoon in 1945 and never came home has none of that. It has only absence, a pure, unlocated absence that cannot be buried or visited or finished with, because it has no coordinates. It exists everywhere and nowhere, like the ocean itself. The mothers of the men of Flight 19 knew this grief. Among them was the mother of Captain Edward Powers, one of the flight's instructors, a young man of 26 who had survived the Pacific War only to vanish on a training exercise off the Florida coast, and the mother of George Devlin, 21 years old, who had enlisted in the Navy at 17 and who was, by every account of the people who knew him, the kind of young man that the world could not afford to lose. These women waded through the search, through the days when the Navy's aircraft and ships combed the Atlantic and found nothing, and then through the weeks after the search was called off, and then through the years. Some of them never fully accepted that their sons were gone. How could they, with nothing to accept? The ocean had not given them a fact. It had given them a question, and a question of that kind does not close. The families of the men of Flight 19 were not alone in carrying that particular weight. The family of Harvey Conover carries it too, though his name is far less known. Conover was a successful New York publisher who, in January of 1958, set out for Miami aboard his sailing yacht, the Revenant, with his wife and 2 friends, bound for a race in Key West. The Revenant was a well-maintained vessel. Conover was an experienced sailor. The passage from Miami to Key West is one of the most frequently made sailing routes in American waters, a route lined with islands and dotted with marinas and rescue resources, not the open Atlantic. And yet the Revenant and everyone aboard her vanished. A search found debris that was tentatively identified as belonging to the vessel, some cushions, a life jacket, but the identification was never certain, and no trace of the 4 people aboard was ever found. Harvey Conover's family spent years trying to understand what had happened to him. They never arrived at an answer that satisfied them, because no answer was available. The ocean had swallowed him and sealed itself over the place where he had been, and all that remained was the question. The human cost of the Triangle's most famous cases runs into the hundreds of individuals, each with a family, each with a story, each with a life that was interrupted and a death that was not witnessed, and a disappearance that was not explained. But there's another category of human experience connected to the Triangle that is less often discussed, and that is the experience of the searchers. The men and women who went out after the disappearances, who flew the search patterns and sailed the search grids and scanned the ocean surface for any sign of the people they were looking for, and who came back again and again with nothing. That experience leaves its own mark. Coast Guard veteran Robert Ulrich spent 17 years stationed in the district that covers the Bermuda Triangle's western approaches, and in that time participated in dozens of search and rescue operations in the Triangle's waters. In interviews given after his retirement, he described the particular psychological texture of a search that finds nothing, the way the mind keeps insisting that the next grid square will yield something, that the next pass over the search area will reveal a debris field or a life raft or a flare, and the way that insistence gradually gives way to a kind of hollow certainty that there is nothing to find. He described the ocean in those moments as feeling not merely empty, but actively resistant, as though it were working against the search rather than simply failing to cooperate with it. He was careful to say that he didn't mean this literally, that he didn't believe the ocean had intentions. But the feeling, he said, was real. The feeling of searching a place that has decided not to give anything back. That feeling of an ocean that withholds rather than merely fails to provide is one of the consistent emotional themes in the accounts of people who have worked extensively in the Triangle's waters. It is, of course, a projection, an attribution of intention to a physical environment that operates entirely without intention or awareness. But projections of that kind are not meaningless. They tell us something about the subjective experience of the place, about what it feels like to be a human being in that particular stretch of ocean, surrounded by that particular quality of water and sky. And the subjective experience of the Bermuda Triangle, as described by those who know it best, is consistently one of heightened awareness, of a sense that the ordinary rules of navigation and prediction apply less reliably here than they do elsewhere, and of a respect, sometimes verging on unease, for the environment's capacity to surprise. Among the most quietly remarkable human stories connected to the Triangle is that of Donald Crowhurst, though his connection to it is oblique and his story belongs more properly to the South Atlantic than to the Western Atlantic. Crowhurst was a British amateur sailor who in 1968 entered the Sunday Times Golden Globe race, a single-handed circumnavigation of the globe. Facing certain failure, he began falsifying his position reports, staying in the South Atlantic while pretending to sail around the world, and the psychological strain of the deception, combined with the isolation of months alone at sea, appears to have broken him. His trimaran, the Timoth Electron, was found drifting in the Atlantic with no one aboard. His logbooks told the story of a mind coming apart, of a man lost not in the ocean, but in himself. Crowhurst's story is not a Bermuda Triangle story, but it belongs in this human chapter because it illustrates something that the Triangle's more dramatic cases sometimes obscure, that the sea's greatest danger is not always meteorological or geological or electromagnetic. Sometimes it is psychological. Sometimes the ocean isolates a person from everything that keeps them anchored to themselves, and what they disappear into is not water, but silence and time and the vast, indifferent blue. The pilots who have flown the Triangle skies extensively describe a version of this psychological dimension that is less extreme, but recognizably related. Flying over open ocean at night, out of sight of any land, with nothing below but water and nothing above but stars, produces a particular state of mind, a state in which the ordinary spatial references that keep a pilot oriented begin to feel less reliable, in which the horizon can be difficult to distinguish from the sky, in which the instruments in front of you become the only reality you can trust. This state is not unique to the Bermuda Triangle. It is a feature of all overwater night flying, but the Triangle's additional variables, its electromagnetic anomalies, and its rapid weather changes, and its peculiar atmospheric effects, can push that state further than it would ordinarily go. Several pilots who have flown the Triangle extensively and spoken about it candidly describe a habit of heightened instrument discipline in that airspace, a conscious, deliberate effort to trust the instruments over the senses, because the senses in that environment can be genuinely deceiving. This is worth dwelling on for a moment, because it speaks to something important about the Triangle's human history. Many of the aviation cases that have been attributed to the Triangle, Flight 19 most prominently among them, involved navigational disorientation as a key factor. And navigational disorientation in an aircraft is not simply a matter of making a wrong turn. It is a profound disruption of the relationship between a human being and their environment. A state in which the pilot's perception of where they are diverges from where they actually are, and in which the instruments that should resolve that divergence are either malfunctioning or being unconsciously disregarded in favor of the senses. In the triangle's atmospheric conditions, where instruments can behave erratically and the visual environment can be misleading, the conditions for this kind of disorientation are unusually well developed. The pilots of Flight 19 were not incompetent. They were experienced, trained, and capable, but they were flying in conditions that systematically undermined the tools, both mechanical and perceptual, that they needed to know where they were. And in that environment, confusion compounded confusion until there was no way back. The human stories of the Bermuda Triangle are, in the end, stories about the relationship between human beings and an environment that exceeds them, an environment that is more powerful, more complex, and more indifferent than anything in ordinary life prepares us to deal with. The ocean does not mean to be dangerous. It does not mean anything. It simply is what it is, vast and deep and governed by forces that operate on scales of time and space that make human navigation seem, from a certain angle, like an act of extraordinary presumption. We cross it anyway, because we have always crossed it, because the other side holds things we need or want or love, because the crossing itself is part of what we are. And sometimes the crossing goes wrong, and the people we send out don't come back, and we are left on the shore with our questions and our grief and the sound of the water, which continues regardless. The Bermuda Triangle has taken from the world a quantity of human life and human potential that is genuinely difficult to contemplate in the aggregate. Individually, each loss is a specific and irreplaceable tragedy. A mother's son, a family's father, a crew of young men who had survived a war only to be taken by a training exercise, a publisher sailing a familiar route on a clear afternoon. Together, they form a kind of ledger of the sea's indifference, a record not of supernatural malevolence, but of the simple, brutal arithmetic of what happens when human beings venture into an environment that does not accommodate human error. The Triangle has been many things in the public imagination: a portal, a mystery, a conspiracy, a manufactured myth. But in the lives of the families who lost people there, it has been something simpler and more devastating than any of those things. It has been the last place, the place where someone went and didn't come back, and where the question of why has no answer that time or science or grief has yet been able to supply. There are still more stories to tell. Stories from the modern era, stories from the deep water, stories that the 21st century has added to the ledger. But they will wait. For now, the shore holds us, and the ocean stretches out beyond it, blue and patient, and full of everything we have put into it, and everything it has taken from us, keeping its accounts in a language we have not yet learned to read. There is a category of story that belongs neither to the realm of the explained nor to the realm of the supernatural, but sits in the uncomfortable territory between them. The territory of the almost understood, the nearly resolved, the case that gets close enough to an answer that you can almost see it before the evidence runs out and the darkness closes back in. The Bermuda Triangle has produced more of these stories than almost any other place on Earth. And they are in some ways the most interesting stories it has to offer, because they reveal something that the dramatic disappearances and the grand theories tend to obscure, that the line between mystery and explanation is not a sharp one. That most genuine unknowns exist on a spectrum that runs from the nearly certain to the genuinely inexplicable, and that the Bermuda Triangle, examined honestly, contains examples from every point on that spectrum. Consider the case of the cargo ship SS Poet, which vanished in October of 1980 while sailing from Philadelphia to Port Said in Egypt, carrying a crew of 34 men and a cargo of grain. The poet was last heard from on October 24th, somewhere in the western Atlantic. No distress signal was received. No wreckage was found. 34 men and a ship of nearly 12,000 tons simply ceased to exist as far as the maritime world was concerned, and the subsequent investigation by the United States Maritime Administration was unable to determine a cause. The poet's disappearance is sometimes listed among the triangle's victims, though her last known position was at the triangle's northeastern edge, and she was heading away from it rather than through it. But what makes the poet's case interesting is not its location. It is the investigation's findings about the ship's condition. The poet was old. She was poorly maintained. Her hatches, the investigators noted, may not have been properly secured, which in heavy seas could allow water to enter the cargo holds rapidly. The grain cargo itself is relevant. Wet grain expands and shifts, and a cargo of grain taking on water can destabilize a vessel with terrifying speed, changing its center of gravity faster than the crew can respond. None of this was proven. None of it was observed. But the investigators noted that a combination of these factors, in the North Atlantic in late October, a notoriously dangerous season in those waters, could account for the loss of a ship without any recourse to the Triangle's mythology. What the poet's case illustrates is something that runs through dozens of the Triangle's less famous disappearances. The role of what investigators call latent failures, the accumulated small deficiencies in a vessel or aircraft's condition or a crew's preparation that don't cause disaster individually, but that combine, under the right circumstances, to make disaster inevitable. A hatch that isn't quite sealed, a compass that's slightly off, a weather report that's 6 hours old, a crew that's tired, a captain who's pushed the departure time to meet a schedule. None of these things is a death sentence in isolation, but in an environment as unforgiving as the Bermuda Triangle's waters, where the margin between a manageable situation and a catastrophic one can be very thin, latent failures have a way of becoming fatal with a speed that doesn't allow for correction. The Triangle doesn't create these failures, but it exploits them the way any extreme environment exploits any weakness in the systems operating within it. The case of a yacht Witchcraft, which disappeared on December 22nd, 1967, illustrates a different dimension of this same dynamic. The Witchcraft was a 23-foot cabin cruiser owned by a hotelier named Dan Burek, who on that December evening took it out with a friend, Father Patrick Horgan, to watch the Christmas lights along the Miami waterfront from the water. They were barely a mile offshore when Burek radioed the Coast Guard a report that his propeller had struck something and that he needed a tow. He was calm in the transmission. There was no indication of danger. The Coast Guard dispatched a vessel immediately, and it arrived at the reported position within 19 minutes. The Witchcraft was not there. No debris, no life jackets, no sign of Burek or Father Horgan. Nothing. A search involving aircraft and multiple vessels found nothing in the hours and days that followed. 2 men, 100 yards offshore from one of the most densely populated waterfronts in America, had vanished between a radio call and a rescue vessel's arrival in less than 20 minutes. The Witchcraft case is remarkable for its specificity, the tight timeline, the known position, the proximity to shore, and it has resisted explanation more stubbornly than almost any other Triangle case. The most plausible theory is that whatever damage the propeller strike caused was more serious than Burek realized, and that the boat sank very quickly once the flooding began, before either man could deploy the life jackets that every boat of that type was required to carry. The Witchcraft was reportedly fitted with flotation devices that were supposed to make her unsinkable, which would mean she should have remained at the surface even if flooded. unless the damage was structural rather than simply a flooding issue, or unless the flotation material had degraded. The Gulf Stream runs close to the Miami shore, and a boat that sank at the reported position could have had its debris dispersed rapidly by the current. But none of this accounts for the complete absence of any trace. No debris, no bodies, no life jackets. Nothing washed ashore in the days and weeks following. 19 minutes. 1 mile offshore. 2 men gone. The witchcraft occupies a special place in the Triangle's catalog because it is so hard to fit into any neat category. It is too close to shore and too well documented to be explained by the open ocean hazards, the rogue waves, the microbursts, the waterspouts that account for many of the Triangle's more remote cases. It is too recent and too specific to be a matter of poor historical documentation, and it happened in waters so familiar and so heavily monitored that the idea of a vessel simply vanishing there without a trace pushes against everything we think we understand about how maritime disasters work. It is, in the most precise sense of the word, inexplicable, not in the sense that no natural explanation is possible, but in the sense that no natural explanation yet proposed fully accounts for all the facts of what happened. Running alongside these human-scale cases in the Triangle's modern history is a thread of technological mystery that has attracted serious attention from engineers and scientists who might otherwise have little interest in maritime legends. The specific phenomenon in question is the failure of electronic navigation and communication systems in the Triangle's airspace and sea lanes. Failures that go beyond what the known electromagnetic anomalies of the region would be expected to produce, and that have been reported with sufficient consistency by credible witnesses that they constitute a genuine dataset rather than a collection of anecdotes. Pilots report GPS systems giving incorrect position data in areas of the Triangle where no known interference source exists. Ships report radar systems showing contacts that aren't there or failing to show contact that are. Radio communications drop out in ways that don't correlate with atmospheric conditions or distance from transmitters. These reports come from professional mariners and aviators, people who work with these systems daily, who know what normal malfunction looks like, and who describe what they experience in the Triangle as something qualitatively different from normal malfunction. The explanation that has gained the most traction among engineers who have examined these reports is related to the same geological and oceanographic features we have already discussed: the methane hydrate deposits, the tectonic activity, the unusual temperature differentials between the Gulf Stream and the surrounding ocean. These features, it has been proposed, create localized electromagnetic fields of sufficient intensity and variability to interfere with sensitive electronic systems in ways that are difficult to predict or reproduce in laboratory conditions. The interference is real, but it is intermittent and location-specific in ways that make it hard to study systematically. You would have to be in the right place at the right time with the right instruments, and the right place and the right time are not reliably predictable. The ocean is large, and the anomalies, if they exist as described, are comparatively small and transient. Finding them deliberately would require a research effort of considerable scale and duration, the kind of effort that has not yet been mounted with the specific goal of characterizing the Triangle's electromagnetic environment in detail. What has been mounted in the early decades of the 21st century is a series of deep-sea search operations that have used advanced submersible technology to look for specific wrecks in the Triangle's deep water, not as Triangle investigations per se, but as maritime archaeology projects that happen to be working in the Triangle's boundaries. Some of these searches have found things. In 2015, a private exploration company using a deep-sea submersible located what appeared to be the wreck of a World War II-era aircraft in the deep water northeast of the Bahamas. an aircraft that matched the profile of a TBM Avenger torpedo bomber, the type flown by Flight 19. The discovery generated considerable excitement, but subsequent analysis was inconclusive. The wreck was too deteriorated and too deeply buried in sediment to be definitively identified, and the Western Atlantic contains a large number of TBM Avenger wrecks from the war years, not all of them related to Flight 19. The find remains unconfirmed as a Flight 19 aircraft, but its existence demonstrates that the deep water search is possible, and that patient, well-funded exploration of the Triangle's abyssal zone may eventually yield identifications that have been impossible until now. Other searches have found things that were not expected and are not easily categorized. Sonar surveys in certain areas of the Triangle's deep water have revealed what appear to be large-scale structural anomalies on the seafloor, formations that have the geometric regularity of constructed objects, but that are too large and too deeply buried for submersible investigation to have yet resolved their nature. Some researchers have suggested these formations are consistent with the kind of massive infrastructure that an advanced prehistorical civilization might have built, a suggestion that brings us back, inevitably, to Atlantis and to the theories that Charles Berlitz explored in the 1970s. The mainstream scientific response to these suggestions is deeply skeptical, and for good reason. The geological processes of the Western Atlantic are well understood, and those processes are capable of producing regular geometric formations of considerable scale without any human assistance. But the formations exist, and their full characterization awaits investigation that hasn't yet been done. What the Triangle's modern chapter reveals, taken as a whole, is a place in transition, a mystery that is being progressively illuminated by technology and science, but that retains, in the illuminated space, a core of genuine uncertainty that the illumination has not yet reached. The dramatic theories of the 1970s, Atlantis, extraterrestrials, time portals, have been largely set aside by serious researchers, not because they have been definitively disproven, but because the evidence for them is thin and the natural explanations for the Triangle's known phenomena are, in most cases, both more plausible and more interesting. But the natural explanations have their own limits, and those limits are where the real questions live. In the cases like the witchcraft, where the timeline and the location and the proximity to shore make the standard explanations feel insufficient. In the electronic anomalies that credible observers keep reporting and that no one has yet fully characterized. In the deep water formations that sonar has revealed and submersibles have not yet visited. The Bermuda Triangle, in other words, is not a solved mystery that is still being marketed as unsolved. It is a partially solved mystery, a collection of questions, some of which have good answers, and some of which do not, arranged around a geographical area that has a genuine and documentable tendency to produce situations that resist ordinary explanation. The percentage of its cases that remain genuinely mysterious, after the errors are corrected and the natural explanations applied, is smaller than the mythology suggests, but is not zero. And in that non-zero remainder, the Triangle continues to live, as it has always lived, at the edge of what we know, looking out into the dark. There is a question that sits beneath all the other questions in this story, and it is not a question about weather or geology or electromagnetic fields or the depth of the Puerto Rico Trench. It is a more fundamental question, and it is one that the Bermuda Triangle poses with unusual force because of the particular shape of its history. The way it has accumulated stories and theories and investigations and debunkings and reinvestigations over decades. The way it has meant different things to different eras. The way it has served simultaneously as a genuine maritime hazard, a cultural phenomenon, a scientific puzzle, and a screen onto which the anxieties and aspirations of Successive generations have been projected. The question is this: what do we do with a mystery that we can neither solve nor dismiss? What is the right relationship between a human being and a question that won't close? This is not an abstract philosophical question in the context of the Bermuda Triangle. It is a practical one, with consequences for the families of the lost, for the scientists and investigators who have devoted careers to the region, for the pilots and sailors who cross it regularly, and who have to decide, each time they do, how much of what they have heard about it to carry with them, and how much to set aside. The triangle demands a response from everyone who engages with it, and the responses it has generated. The full spectrum from credulous belief to dismissive skepticism tell us as much about the people giving the responses as they do about the triangle itself. The credulous response is easy to understand. When the evidence is ambiguous, when the official explanations feel insufficient, when the people who were lost were real and the absence of answers is genuine, the human mind reaches for a framework that can contain the mystery, that can give it a shape and a cause, and, crucially, a boundary. The supernatural theories of the triangle serve this function. Atlantis, extraterrestrials, time portals. These are frameworks that explain the mystery by locating it outside the ordinary world, by saying that what happened in the triangle happened because forces beyond human understanding were at work, and that the absence of evidence is itself evidence of how powerful those forces are. This is not a logically satisfying framework, but it is a psychologically satisfying one because it closes the question. It says, you cannot understand this, and here is why. And there is, in that answer, a kind of relief. The dismissive response is equally understandable, and in some ways more intellectually respectable, but it has its own problems. The debunkers, Kush foremost among them, performed a genuine and valuable service by correcting the factual errors and the selective reporting that had inflated the triangle's mystery beyond what the evidence warranted. But in their eagerness to demonstrate that the mystery was manufactured, some of them overcorrected, arguing not just that specific claims were wrong, but that there was nothing genuinely unusual about the region at all, that it was statistically indistinguishable from any other comparable ocean area, that the disappearances were entirely explicable by ordinary hazards, and that anyone who found the triangle interesting was a victim of credulous journalism and wishful thinking. This position is too strong. The genuine cases, the ones that resist ordinary explanation even after the corrections are applied, are real. The electromagnetic anomalies reported by credible observers are real. The unusual concentration of dangerous natural phenomena in a single region is real. Dismissing all of it as mythology requires a selectivity about the evidence that is not so different in its own way from the selectivity it is criticizing. The honest response, the one that the evidence most clearly supports, is harder to hold because it requires sitting with uncertainty in a way that neither the believers nor the debunkers are entirely comfortable with. It requires saying, some of this is explained and some of it is not, and the boundary between those two categories is not always clear, and that is simply where we are. It requires acknowledging that the ocean is genuinely dangerous and the triangle is genuinely complex, while also acknowledging that the complexity is natural rather than supernatural, while also acknowledging that natural complexity of sufficient depth and scale can produce phenomena that look, to human observers, very much like something beyond nature. It requires holding the scientific explanation and the human mystery in the same hand without collapsing one into the other. And that is a difficult thing to do because the mind wants resolution and the triangle offers something more uncomfortable, indefinite, ongoing, irreducible uncertainty. That uncertainty has produced, over the decades, a remarkable body of human response. The literature of the Bermuda Triangle, not just the popular books and the magazine articles, but the serious investigations, the academic papers, the official reports, constitutes a kind of running conversation between humanity and one of its most persistent unanswered questions. It is a conversation that has changed over time, that has incorporated new evidence and new tools and new frameworks as they have become available, that has been conducted simultaneously in the languages of science and journalism and folklore and personal testimony. And what is striking about that conversation, reading it whole, is how much more interesting it is than either the credulous or the dismissive position would suggest. The truth of the Bermuda Triangle, the actual, documented, investigated truth, is stranger and richer and more genuinely puzzling than the Atlantis theory, because the Atlantis theory closes the question while the truth leaves it gloriously, productively open. Consider, for instance, the ongoing scientific investigation of the methane hydrate hypothesis. When Joseph Monahan and David May proposed in 2003 that methane hydrate eruptions on the ocean floor could destabilize ships on the surface, the proposal was received with interest but also with skepticism. It was a plausible mechanism, but there was no direct evidence that it had actually caused any specific maritime disaster. In the years since, however, the scientific understanding of methane hydrate deposits in the Western Atlantic has grown considerably, and what researchers have found is that the deposits in the triangle's boundaries are among the largest and most active in the Atlantic basin. Surveys have identified multiple sites where the seafloor shows evidence of recent gas release, areas of disturbed sediment, crater-like depressions in the seafloor, and columns of gas bubbles rising through the water column that can be detected by sonar. These are not hypothetical features. They are documented, mapped, observable phenomena occurring in the Triangle's waters right now, in the present, as part of the ordinary geological activity of the region. The hypothesis that they could, under the right conditions, destabilize a surface vessel has not been proven, but it has moved from speculation to serious scientific possibility, supported by documented physical evidence on the seafloor. The rogue wave research has followed a similar trajectory. The satellite data that confirmed rogue waves were real and far more common than previously believed has continued to accumulate, and the Western Atlantic has continued to emerge as one of the ocean regions most favorable to their formation. Researchers have now documented rogue waves in the Triangle's waters using satellite altimetry, direct measurements of ocean surface height from space. And the picture that emerges is of a sea state that is, in certain meteorological conditions, capable of producing waves of catastrophic size with very little warning and very little trace. The wave comes and goes in minutes. What it strikes is destroyed. What is destroyed sinks into water that is, in parts of the Triangle, thousands of feet deep, and the sea returns to its ordinary state, as though nothing happened, because for the sea, nothing did. What both of these lines of research share is a quality that the Triangle's mythology conspicuously lacks. They are falsifiable. They make predictions that can be tested, evidence that can be gathered, hypotheses that can be confirmed or disconfirmed by data. The methane hypothesis predicts that the seafloor in certain areas of the Triangle should show specific geological signatures, and those signatures have been found. The rogue wave hypothesis predicts that extreme wave events should occur in the Triangle's waters with measurable frequency, and satellite data confirms that they do. These are not proven causes of specific disappearances, but they are real phenomena operating in the Triangle's waters, capable in principle of causing exactly the kind of disasters the Triangle is known for. The gap between capable in principle and proven in specific cases is the gap that the available evidence cannot yet bridge. because the evidence from the disaster sites is precisely what the disasters themselves destroyed. The triangle also continues to generate new cases because the ocean does not retire, and neither does the traffic that crosses it. In July of 2015, a cargo ship called the El Faro sailed from Jacksonville, Florida, into the path of Hurricane Joaquin and sank in the waters east of the Bahamas, taking all 33 of her crew with her. El Faro's position at the time of her sinking placed her at the eastern edge of the Bermuda Triangle's boundaries. Her loss was not a mystery in the Triangle's traditional sense. Her voyage data recorder was eventually recovered from the seafloor at a depth of nearly 15,000 feet, and the recording it contained told a detailed and heartbreaking story of a crew trying to manage a deteriorating situation as the hurricane closed around them and the ship's systems failed one by one. The El Faro investigation was thorough, its findings clear, its lessons about maritime safety specific and actionable. It was, in the language of accident investigation, a solved case. But the El Faro belongs in this story because of what its recovery required. A search operation of extraordinary technical sophistication, using deep-sea vehicles operating at the very edge of their capability, in waters that gave up their secrets only after months of effort and millions of dollars of expenditure. If the El Faro had sunk in 1945 rather than 2015, or if her voyage data recorder had not been recovered, she would have been another triangle mystery, a ship that sailed into a hurricane's path and vanished without explanation, her fate subject to the same speculation and theory building that has attached itself to every other unexplained loss in those waters. The difference between a solved case and an unsolved one in the Bermuda Triangle is everywhere, is often simply the difference between having the technology to find the evidence and not having it. The mystery is frequently not in the event, but in the investigation. This is perhaps the most important insight the Bermuda Triangle's history offers. That mystery is not a fixed property of events, but a variable one, dependent on the tools and methods available to investigate them. The disappearances that seemed inexplicable in 1945 or 1967 or 1980 seemed so partly because the investigative tools of those eras were genuinely inadequate to the environment. The ocean was too deep, too large, too dynamic for the search methods then available to reliably find what had been lost. As those methods have improved, the proportion of genuinely inexplicable cases has decreased. Not to zero, not yet, and perhaps not ever, but measurably, documentably, in ways that show the direction of travel, even if the destination is not yet in sight. The triangle is becoming, slowly and incompletely, more understood. And what understanding it has brought has not diminished its interest. It has deepened it, because the more we understand about what the triangle actually is, about its geology and its oceanography and its meteorology and its electromagnetic properties, the more clearly we can see that it is a place of genuine, remarkable, scientifically fascinating complexity. A place where the planet's interior processes, its atmospheric systems, its ocean currents, and its electromagnetic environment all interact in ways that are unusual and in some respects still poorly characterized. A place that has been the site of real tragedies and genuine mysteries and important scientific discoveries. A place that has served the human imagination as a canvas for its fears and its appetite for the unknown, and that has repaid that imagination with stories that, whatever their ultimate explanation, are genuinely worth telling and genuinely worth hearing. The ocean does not care about any of this. It does not know that it is famous. It does not know that it has a name, or that the name appears in books in dozens of languages, or that people on every continent have wondered about it and theorized about it and been frightened by it. The ocean simply continues, its currents running, its weather building and dissolving, its floor shifting in the deep dark beneath thousands of feet of water, its surface catching the light in the morning and losing it in the evening, day after day, season after season, century after century. And somewhere in those waters, in the deep places where the pressure is absolute and the darkness is complete, lie the answers to the questions that have occupied us throughout this story. They are there. They exist. The ships that sank, the planes that fell, the crews that were lost, they went somewhere, and they are somewhere still. The ocean knows where, and in its own time, on its own terms, in ways and on a schedule that no human investigation has yet been able to compel, it will decide what it gives back. There is a particular kind of ending that a story like this one resists, and it is the tidy kind. The kind where the loose threads are gathered and the questions are answered, and the mystery is resolved into something that can be summarized in a sentence and carried away from a page. The Bermuda Triangle does not offer that ending, and it would be dishonest to pretend that it does. What it offers instead is something rarer and, in its own way, more valuable. A genuine encounter with the limits of human knowledge, a reminder that the world is larger and stranger and more complex than our maps of it, and that the blank spaces on those maps are not failures of cartography, but honest acknowledgments of how much remains beyond our current reach. This final chapter is not a conclusion in the conventional sense. It is more like a shore, a place to stand and look back at the water we have crossed together, and then to look forward at the water that remains. We began this story in the ancient past, with Columbus and his confused compass and his dancing light on the water, and we have moved forward through centuries of maritime history, through the age of sail and the age of steam and the age of aviation, and into the satellite era of the present day. We have met the men of Flight 19 and the crew of the Marine Sulphur Queen and the passengers of the Star Tiger and the sailors of the Ellen Austin and the owners of the Witchcraft and the 33 souls aboard the El Faro. And we have tried to understand not just what happened to them, but what their stories mean, what they tell us about the ocean and about ourselves and about the relationship between the two. We have examined the scientific explanations, the rogue waves, and the methane hydrates and the Gulf Stream dispersal and the electromagnetic anomalies, and we have found them genuinely illuminating, genuinely important, and genuinely incomplete. We have looked at the supernatural theories and found them psychologically understandable and evidentially thin. And we have arrived, at the end of all that looking, at a place of honest, informed uncertainty, the most intellectually respectable place that this particular subject permits. What does that uncertainty actually consist of, in concrete terms? It consists, first, of the handful of cases that resist natural explanation even after the most careful analysis. Cases like the Witchcraft, where the timeline and the location and the proximity to shore make the standard oceanographic and meteorological explanations feel insufficient, and where no alternative explanation, natural or otherwise, fully accounts for all the known facts. These cases are fewer than the mythology suggests, but they are real, and their reality matters. It consists, second, of the electromagnetic and navigational anomalies that credible, experienced observers continue to report in the Triangle's airspace and sea lanes. Anomalies that have natural explanations in principle, but that have not yet been fully characterized or measured in the specific, localized ways that would be necessary to confirm those explanations in the specific cases where they are invoked. It consists, third, of the deep water seafloor, which modern sonar has revealed in unprecedented detail, but which has still been physically visited only in the tiniest fraction of its vast extent, and which almost certainly contains wrecks and formations and physical evidence of past events that no human eye has yet seen. And it consists, finally and most fundamentally, of the simple, irreducible fact that the ocean is very large and very deep and very old, and that human beings, for all the sophistication of our technology and the rigor of our science, are newcomers to it, visitors in an environment that evolved over billions of years before we arrived, and that will continue long after we are gone. Our understanding of the ocean, even today, is partial. Our mapping of its floor is less complete than our mapping of the surface of Mars. Our knowledge of the processes that occur in its deepest regions is limited by the extraordinary difficulty of working in an environment where the pressure would destroy an unprotected human body in seconds. We know a great deal. We do not know nearly enough. And the Bermuda Triangle sits in that gap between what we know and what we don't, as it has always sat, patient, indifferent, and genuinely, stubbornly mysterious. What will the future bring to this story? There are reasons to think that the next few decades will be transformative for our understanding of the deep ocean generally, and of the Bermuda Triangle specifically. Autonomous underwater vehicles, robotic submarines that can operate without a crew at depths and for durations that human-crewed submersibles cannot manage, are becoming increasingly capable and increasingly affordable, and they are already being used for deep-sea survey work in multiple ocean basins. Within the lifetimes of people alive today, it is plausible that the deep water floor of the Bermuda Triangle will be mapped in the kind of detail that allows specific wrecks to be identified and visited, that the question of where Flight 19's aircraft came to rest, for instance, will finally have a definitive answer, located on a chart, photographed by a robot, confirmed by serial numbers corroded, but still legible on metal frames that have been sitting in the dark for 80 years. The technology to do this already exists in prototype form. The resources and the will to deploy it at the necessary scale are what remain to be assembled. The climate science of the coming decades will also contribute to the Triangle story in ways that are not yet fully predictable. The ocean is warming, and a warmer ocean is a more energetic ocean. More powerful storms, more intense hurricanes, more frequent extreme weather events of the kind that have historically been responsible for the majority of the Triangle's maritime losses. If the trends of the present continue, the waters of the Western Atlantic and the Caribbean will become more dangerous for maritime and aviation traffic in the decades ahead, not less. The Triangle's reputation as a place of unusual peril may, paradoxically, become more warranted in the future than it has been in the past. Not because of anything supernatural, but because the natural forces that have always made it dangerous are being intensified by processes that are entirely human in origin. The Triangle is a mirror, and what it is beginning to reflect is our own impact on the systems that govern it. The methane hydrate situation carries a similar and even more acute dimension of climate relevance. The methane hydrate deposits that sit beneath the Triangle's seafloor are, like methane hydrate deposits throughout the world's oceans, sensitive to temperature. As the deep ocean warms, a process that is occurring more slowly than surface warming, but that is already measurable, the stability of those deposits decreases. The conditions under which a methane hydrate deposit might destabilize and release its gas become easier to meet. The frequency with which the seafloor in the Triangle's waters produces the kind of gas eruption that could, in the methane hypothesis, endanger surface vessels may increase as the century progresses. We are, in a very real sense, running an experiment on the ocean's geological systems. And the Bermuda Triangle is one of the places where the results of that experiment may become visible in the most direct and consequential way. There is something almost poetic about this dimension of the story. The idea that a place which has for so long been associated with mysterious Inexplicable forces may be on the verge of becoming more dangerous for reasons that are entirely explicable, entirely human, and entirely preventable if the will to prevent them existed. The Triangle began this story as a place where nature exceeded human understanding. It may end it as a place where human activity exceeds nature's tolerance. That would be a different kind of mystery. Not the mystery of what the ocean is doing, but the mystery of why we continue to do what we're doing to it. But we are getting ahead of the evidence, and this is not a story that should end in speculation, however well-founded. What it should end in is what it has always been about, at its deepest level, the water. The specific, physical, actual water of the Western Atlantic and the Caribbean, which has been flowing through the boundaries of the Bermuda Triangle since long before anyone thought to name it, and which will continue flowing long after the name has been forgotten. That water has a temperature and a salinity and a current and a color that changes with the depth of the light and the angle of the sun and the passage of the seasons. It has a surface that is sometimes flat as glass and sometimes broken into waves of terrifying height. It has a floor that ranges from reef systems barely submerged below the keel of a passing sailboat to abyssal trenches so deep that light has never reached them and never will. It is home to an extraordinary diversity of life, to the fish and the corals and the whales and the sharks and the countless organisms that have no common names because human beings have not yet gotten around to naming them all. It is, in the most basic and important sense, a living system, dynamic, responsive, extraordinarily complex, and not yet fully understood. The ships and the planes that have been lost in it are part of its history now, incorporated into the physical fabric of the place in the way that all things eventually are, rusting on the seafloor, becoming substrate for coral growth, their metals dissolving slowly into the water column, their stories persisting in the memories of the people who cared about them, and in the records that human civilization keeps of its encounters with the sea. They are not gone in the sense of being annihilated. They are gone in the sense of being transformed, changed from one kind of presence into another, from objects moving through the ocean into objects that the ocean has claimed and is slowly, patiently, in its own geological time, absorbing into itself. The Bermuda Triangle will continue to be discussed, investigated, theorized about, debunked, and re-examined for as long as human beings are curious about the world and honest about the limits of their understanding. It will generate new cases, because the ocean is not finished and neither is the traffic that crosses it. It will generate new theories, because the human mind is not satisfied with incomplete answers and will keep reaching for frameworks that can contain what the evidence alone cannot. It will generate new science because the tools of investigation keep improving and the questions keep proving worth the effort of pursuing them. And it will retain, through all of that, a core of genuine mystery. Not the theatrical mystery of the supernatural theories, but the quieter and more durable mystery of a place that is real and complex and dangerous and not yet fully known, and that is taken from the world things that the world would very much like to have back. That is the Bermuda Triangle as it actually is, stripped of the mythology, but not of the wonder, a stretch of ocean like no other, not because supernatural forces have chosen it for their operations, but because the natural world has concentrated in its boundaries a remarkable array of forces and phenomena that interact in ways both understood and not understood, and that have produced, over the centuries, a history unlike any other piece of ocean on the surface of the earth. It deserves the attention it has received. It deserves the seriousness with which its best investigators have approached it. And it deserves, perhaps most of all, the respect of honest acknowledgement, the acknowledgement that we do not know everything that has happened there, that we may never know some of it, and that the not knowing is not a failure but a fact, as real, and as significant as any of the facts we have managed to establish. The water is still out there, blue and deep and patient and full, and somewhere beneath its surface, in the dark, the answers wait, as they have always waited, for us to become capable of finding them. There is a category of place in the world that exists simultaneously as a physical location and as a state of mind, a place so thoroughly inhabited by human imagination that it becomes, over time, two things at once. The actual geography, with its coordinates and its weather and its water, and the idea of itself, which is something larger and stranger and more enduring than any map can contain. The Bermuda Triangle is one of those places. Stonehenge is another. The Amazon is another. Easter Island, the Mariana Trench. These are places where the physical reality and the human response to it have become so intertwined that separating them feels not just difficult but somehow beside the point, as though the intertwining is itself part of what the place is, part of what makes it significant, part of what it has to teach us. And what the Bermuda Triangle has to teach us in this chapter is something about the specific and remarkable way that human beings have responded to it over time. Not the scientists and the investigators, whose responses we have already examined at length, but the artists and the writers and the filmmakers and the storytellers. The people whose job it is not to explain the world, but to reflect it back to us in forms that illuminate what it feels like to be alive inside it. The triangle entered popular culture gradually, and then all at once. For most of the first half of the 20th century, it existed primarily as a matter of maritime and aviation record, a set of incidents documented in official reports and maritime journals, known to sailors and naval investigators, but not yet part of the broader cultural conversation. Vincent Gaddis named it in 1964. Charles Berlitz made it famous in 1974. And between those two moments, something happened that is interesting in retrospect. A 10-year period during which the triangle existed as a named phenomenon, without yet being a cultural phenomenon, during which it was accumulating the critical mass of public awareness that would eventually make Berlitz's book not just a bestseller, but a genuine cultural event, the kind of book that changes the way a generation thinks about a subject. That accumulation happened through newspaper articles and magazine pieces and word of mouth, and the particular way that a compelling, unresolved story spreads through a society that doesn't yet have the internet to spread it for them. Slowly, laterally, person to person, each telling adding something to the story, and the story growing with each telling. By the mid-1970s, the triangle had become a genuine cultural obsession, and the creative response to it was immediate and prolific. Films appeared, most notably the 1978 documentary that carried Berlitz's book title to cinema screens and introduced the triangle's mysteries to audiences who would never have read the book. Television specials followed, then dramatizations, then the first wave of fictional treatments that used the triangle not as a documentary subject, but as a setting, a place where strange things could happen to fictional characters for narrative reasons, a geography of the inexplicable that writers could deploy without having to justify or explain. The triangle became, in the language of narrative craft, a useful device, a location that arrived preloaded with atmosphere, pre-charged with dread, that could be invoked with a few words and would immediately communicate to an audience a specific set of expectations about what kind of story they were in. This narrative utility has made the triangle one of the most persistently useful locations in popular fiction, and it has been used in ways that range from the genuinely creative to the thoroughly cynical. At its best, the fictional treatment of the triangle has explored the genuine philosophical questions it raises. Questions about the limits of knowledge, the nature of fear, the relationship between human beings and environments that exceed their understanding. At its worst, It has simply deployed the triangle's atmosphere as a shorthand for cheap menace, using the location's reputation to do work that the story itself should be doing. The difference between these two approaches is the difference between using a place and understanding it, and the triangle's fictional history contains examples of both in abundance. Among the most interesting of the creative responses to the triangle is its presence in music, specifically in the genre of progressive rock, which in the 1970s was engaged in an extended, ambitious project of transforming the concerns of classical composition and literary narrative into the medium of electric guitar and synthesizer. The triangle became a subject for several concept albums of the era, most notably a 1978 album by the American rock group simply titled Bermuda Triangle, which attempted to capture in sound the atmospheric quality of the place, its strangeness, its danger, its quality of being a threshold between the known and the unknown. The album was not a commercial success, but it illustrates something important about the triangle's cultural penetration at that moment, that it had become a subject rich enough, evocative enough, and widely enough understood to sustain an extended artistic treatment in a medium that had nothing to do with maritime history or oceanography. The triangle had become, by the late 1970s, part of the shared imaginative vocabulary of Western culture, the way that certain myths and certain places always do when they strike deep enough into the collective imagination. The triangle's presence in literature has been similarly varied and persistent. It has appeared in thrillers and in science fiction and in horror and in literary fiction, used for different purposes in each genre, but always drawing on the same core of genuine mystery and genuine danger that makes it so adaptable to narrative use. In thrillers, it provides a setting of authentic menace, a place where characters can face genuine, documented peril rather than manufactured threat. In science fiction, it serves as a portal to otherness, a location where the boundaries of the known world are thin enough that what lies beyond them can push through. In horror, it is simply fear made geographical, a place where the thing you cannot see and cannot name can reach out of the darkness and take you. And in literary fiction, at its most thoughtful, it has been used as a meditation on the relationship between human beings and the natural world, on the presumption involved in crossing an environment that does not want to be crossed, and on the cost of that presumption when the environment declines to cooperate. The internet age has done something interesting to the triangle's cultural life. In the early years of the web, the triangle was one of the first great mysteries to find a home in the new medium. There were dedicated websites and discussion forums and amateur investigations from the earliest days of the public internet, attracting communities of enthusiasts who brought varying degrees of rigor and creativity to their engagement with the subject. But the internet has also, over time, subjected the triangle to a different kind of scrutiny than it had previously faced. The scrutiny of crowdsourced fact-checking, of easily accessible primary sources, of a culture that has become increasingly sophisticated about the difference between a compelling narrative and a documented fact. The debunking impulse, which had always existed in the triangle's literature, but which had required the kind of sustained, archival research that Lawrence Kusch devoted years to, became in the internet age something that any motivated individual with access to the right databases could perform from their own home. Specific claims about specific cases could be checked against historical records in minutes. The inaccuracies that had accumulated in the popular literature, the storms that weren't mentioned, the disappearances that occurred outside the triangle's boundaries, the ships that had actually been found, could be identified and corrected with a speed and ease that Kusch would have found extraordinary. The result has been a gradual, uneven, but real shift in the public understanding of the triangle. A shift away from the uncritical belief in the supernatural theories that characterized the 1970s peak and toward a more nuanced position that acknowledges both the genuine mysteries and the manufactured ones, that takes the science seriously while remaining open to the cases that the science doesn't fully explain. This shift is not complete, and it is not uniform. The Triangle's mythology retains a powerful hold on large portions of the public imagination, and the supernatural theories continue to find new audiences in each generation that encounters the subject for the first time. But the conversation has changed, and changed for the better, and the internet, for all its well-documented tendency to amplify misinformation, has in this particular case served as a corrective as much as an amplifier. The documentary tradition has evolved in parallel. The early Triangle documentaries of the 1970s were, by modern standards, credulous to a fault. They presented the supernatural theories without serious challenge, used dramatic reconstruction and atmospheric music to create an emotional experience of mystery that overwhelmed any inclination toward critical thinking, and left audiences with the impression that the Triangle was a place of confirmed, documented supernatural activity. Later documentaries, particularly those produced in the 1990s and 2000s, began to engage more seriously with the scientific explanations and with the debunking work that had accumulated in the intervening years, presenting a more balanced picture that acknowledged both the genuine hazards of the region and the exaggeration that had accumulated around them. The most recent generation of Triangle documentaries, produced in the era of deep-sea exploration technology and satellite oceanography, has been able to incorporate actual footage from the deep water environments where the Triangle's secrets lie. Images of wreckage on the seafloor, real-time sonar data, the testimony of scientists who have spent careers studying the region's specific physical properties. These documentaries are, in the main, better than their predecessors, more accurate, more rigorous, more honest about the distinction between what is known and what is not. And yet something is also lost in the evolution toward rigor, or at least something has changed. The early Triangle documentaries, for all their credulity, captured something real about the emotional experience of the mystery, the genuine sense of confronting something that exceeded human understanding, the authentic feeling of standing at the edge of the known and looking out into darkness. That feeling is not manufactured. It is a real response to a real place, and it is as much a part of the Triangle story as the meteorological data and the insurance actuarial tables. The corrective impulse, taken too far, risks replacing one kind of distortion with another, replacing the distortion of credulity with the distortion of reductive explanation. The distortion that says because we can explain most of it, we can explain all of it, and because we can explain all of it, there is nothing left to feel. There is something left to feel. The families of the lost feel it. The searchers who came back empty-handed feel it. The pilots and sailors who have crossed the Triangle's waters and returned with strange things to report feel it. And anyone who sits with the genuine cases, the Witchcraft Flight 19, the Star Tiger, the Marine Sulphur Queen, and gives them the full weight of their attention, who allows the specific details of specific human lives ended in specific and unexplained ways to register with the force they deserve, will feel it too. It is not the feeling of confronting the supernatural. It is the feeling of confronting the natural world in its full, overwhelming scale and complexity, of understanding, in a way that ordinary life rarely requires us to understand, how small we are and how large it is, and how thin the margin is between the ordinary day and the extraordinary last moment. The Bermuda Triangle has been, throughout its cultural life, a mirror. What people have seen in it has reflected what they brought to it. The Cold War generation saw portals and aliens and Atlantean energy crystals, because those were the metaphors available to them for forces that exceeded human understanding. The scientific generation saw statistical anomalies in natural phenomena and manufacture mythology, because those were the frameworks they trusted to make sense of a complicated world. The internet generation sees a case study in misinformation and a lesson in critical thinking, because those are the concerns most urgent to them. Each of these responses captures something true, and each of them misses something. The triangle is larger than any single response to it. It always has been. What it is, in the end, is a place. A real place, with real water and real weather and a real floor far below, where real ships and real planes and real people have come to rest after real disasters that had real causes, most of which we understand and some of which we do not. It is a place that has earned its reputation, not through supernatural selection, but through the ordinary, relentless operation of natural forces that are genuinely unusual in their concentration and their interaction. It is a place that deserves respect, the practical respect of mariners and aviators who must cross it, and the intellectual respect of a culture that takes its mysteries seriously enough to investigate them honestly, without either inflating them into the supernatural or deflating them into the merely statistical. The stories we have told in this series, the stories of the men who flew and the sailors who sailed and the families who waited and the searchers who found nothing and the scientists who kept looking, are all part of a larger story that the ocean itself is telling, in the only language it has, which is the language of what it does and what it takes and what it gives back over centuries and millennia, in the blue and restless water between Florida and Bermuda and Puerto Rico, at the intersection of the known world and the edge of everything else. This concludes our journey through the history of the Bermuda Triangle. If you're looking for resources to help you relax and fall asleep naturally, be sure to check out the link in the description below. Don't forget to like this video, and be sure to subscribe and turn on notifications so you know when the next journey through history is ready to embark on. Thanks again, and have a good night.